Hi everybody, it's Miss B. Hope you had a great weekend and that you're ready for another topic in blood spatter analysis. Now, last week you were tasked with doing 3 mini labs to help you in discovering what really makes that blood shape that you see and what you can tell from it. Now, today we're going to be adding on to that. I'm going to be showing you how you can use careful measurements from blood spatter to figure out in 3-dimensional and 2-dimensional space where the blood spatter originated at a crime scene. So last week we learned about blood angle of impact of drops and how when blood is dropped from straight above, there's probably a much circular shape to that blood spatter. However, when it hits at different angles, they have more oval or elongated shapes, as you can see here, right? 90 degrees, very circular. And as we get at higher and higher angles, or lower if you'd like to say, you have a much more extreme shape. Now today, we're going to be doing some math to figure out some very exact things about the shape and size of blood drops when it hits a surface, and then use some other measurements and calculations to figure out where in 3D space that blood originated. So this can help you to figure out if the person was standing or if they were kind of crouched low to the ground, wherever this blood originally flew from. It can also maybe give you an idea of the height of the person that this happened to. Okay. So here's some math that we're going to come across. You've probably seen a little bit of this before, right? We're going to be doing a little bit of trigonometry using triangles. You may have also seen these, sine, cos, and tan, or SOHCAHTOA. And we're going to be using these, but mostly we're going to be focusing on sine, okay? To find the sine of our angle, we are going to be needing some measurements, mainly the hypotenuse and the opposite side of a triangle. Now the hypotenuse is the longest side of a triangle. So on these triangles here down below, this is the hypotenuse, this one's the hypotenuse, and this one right here as well. The opposite is just the side that is opposite from the angle that we are trying to find. So in this case, it'd be here. And you'll notice that the sine of our angle is equal to the length of the opposite side of that angle divided by our hypotenuse. All right, so if you're not comfortable with this type of math, we're going to go through it a little bit step by step. However, feel free to follow along or go ahead if you're already comfortable with this idea. So here we go. Okay. So you may wonder about why triangles have anything to do with blood spatter, right? Blood doesn't spatter in a triangular shape. Let me show you. So let's imagine that this is a side view of a blood drop that is flying through the air, and it's going to impact on this surface down here. Maybe that's the ground, a table, whatever it is. It's a solid surface. And if we put some lines in right here to show the pathway of that droplet, we can actually see that down here, the pattern that it's going to make, that blood is going to make that oval elongated shape. It's not going to be a perfect circle. Okay. Now this is actually our hypotenuse for our triangle. Now that it's going to turn into that oval shape, there's something else that we also need to look at. Another thing I want to point out is that a blood droplet is circular while it's flying through the air. Now the width of that blood droplet is what makes our opposite side. Okay, so this is our opposite side of our triangle, and you can see how that actually makes our right angle right here for us. Now, the last thing that we need to look at is our angle, right? So that's going to be right here. This is the angle that we are looking for. And remember, the sine of the angle is equal to the opposite side of my triangle divided by the hypotenuse of my triangle. So if we look at a blood droplet from a top view, say this is afterwards, crime has happened, and now we see these blood stains, we can carefully measure the length and the width of our blood droplet, and now we can figure out the sine of that angle. Okay, so I can take my length, I can take my width, which I'd carefully measure with a ruler or a pair of calipers, and I can figure this out. Remember, the sine of the angle equals width divided by the length. Or I can switch this around so it's a little bit easier for me to understand. I can just say the angle, which is what I'm really trying to find, is equal to the inverse sine of the width divided by the length of my blood spatter. Now we can put this into a scientific calculator to help calculate that angle, and I'm going to show you in a few minutes how to do that. But just wanted to reiterate, what's really interesting, what's a really cool thing, is that this measurement is taken after the crime, okay? But it can tell you what was happening during the crime. So you can find out what angle the blood was hitting the surface at, which can give you a better idea of where these blood droplets may have originated from. So you can use these measurements to give you a fuller idea. Was the blood coming from very high up in the room, very low in the room, different things like that. Okay, oh, and there's one more thing that I wanted to point out. Sometimes you also have these spines attached to your blood droplet, and you might think, okay, what about those? What do I do? When you have a spine, giant blob, how do you measure that perfect oval? And the answer is you draw or imagine the end of the perfect oval shape, and you use that and measure its length. So I would cut off the tail here and just make that perfect oval shape, and this is what I'm going to be using to calculate my length. All right, so here, let's go through an example together. So I have this very pixelated blood spatter. Sorry about that. And very first thing I need to do is I need to cut off this tail here and just make it into that perfect oval shape. So that's what I've done here. You can either do this in pencil or you can just kind of eyeball it, for lack of a better word. Okay, so here I go. I'm measuring my length of my blood droplet, the longest portion, and let's say that it's about 16 millimeters. I'm going to go ahead and measure my width, and let's say that's about 8 millimeters. Now, I always want to make sure when I'm measuring these that I'm using the same units. Okay, I'm going to go ahead and look at my formula here. So I want to find out the angle of that blood, what angle it hit the floor at. So I'm going to use the inverse sine with my width divided by length. So 8 millimeters divided by 16. And we're going to punch this into a scientific calculator. If you have one on you, that's awesome, and you can just use it that way. However, I'm also going to show you how you can use the internet to your advantage right now. So what you can do is just look up a scientific calculator on the Google. I tend to use Desmos right here. You just type in scientific calculator, and this one pops up. And so the very first thing that we need to do is look for sine, cosine, tan, but I want the inverse sine. So we're going to go to functions here, and you will find the inverse. Now I can go back to my main menu, and I need to have 8 divided by 16. All right, now we're just going to close the bracket, and it gives you your answer right away, which is 30. So I know that if I go back here, My angle that this blood hit the ground at was a 30-degree angle, and that is fairly low, a little high, but it gives you an idea, especially if you're looking on a protractor now, how high that blood was when it hit the ground, that angle. We're also going to be using a little bit of this math tomorrow to learn a little bit more about how to figure this out in three-dimensional space. But for the rest of today's lesson, I would like you to practice using this formula. So you're going to use this formula here to calculate the angle for 3 different blood spatters. It's in a small Google assignment attached to this post. If you have any questions, please feel free to send me an email and I will help you through each step of the way. I hope you have a great day, everybody, and good luck calculating your blood angles.